Hello everyone, and welcome to our video on instantaneous rates of change and the definition of a derivative. So derivatives are from our difference quotient. So I'm going to box this up first. So we saw this, so if you're going in order of these videos, the difference quotient is this fraction. And so we saw it in these table ones. Okay, so it is this fraction. And well, they started to say, well, that h we kept shrinking. Also in this table, we said, oh, let's make it smaller and smaller and smaller. Well, the smaller that it gets, it turns out that that's something very important as it gets very close to 0. So as our h gets close to 0, so just draw like a random sketch real quick. So we talked about secant lines. So from that dot to that dot, we would say makes a line if we draw it. So this is a secant line. But we also said that there's a horizontal distance. Let's put that in pink right here to measure the rise and run. Well, if this h gets very close to 0, what's going to happen here? So let's do it in blue. So that means, so this distance gets so here's a smaller h. Okay, so, and even smaller and smaller and smaller. What's happening then is this dot or this point along the graph is getting closer and closer and closer and closer to the original dot. And so they basically become stacked on each other and we get a new line. So this new line is called a tangent line. Oh, let me try to spell it a little better. Okay, so tangent line. There. So that's the tangent line. Okay, so it's a line that just touches the graph. And so what it does is it gives an instantaneous rate of change. Okay, so its slope is an instantaneous rate of change. So we said the secant line was an average rate of change. So its slope was average rate of change. Okay, so this is telling us an instantaneous change. So for instance, like if you watch tennis or baseball, when they show like a server's speed or a pitcher's speed, they are talking about an instantaneous speed. So an instantaneous rate of change. So it's the speed or velocity that the ball is taking as soon as it leaves the racket or as soon as it leaves the pitcher's hand. So it's not an average. So an average rate of change would be measuring the speed or velocity after the distance that it traveled. Okay, so that wouldn't be as impressive. So when you see like a 100-mile-per-hour fastball, so the when it gets to the batter, it's not going that fast as it is when it's leaving the pitcher's hand. So not as impressive. So they want the fastest instantaneous speed that's possible. Okay, so but that's like the difference between the two. Okay, and that's the visual of it. So for instance, going back to this, so it says going back to my trip to Reno from Mina, what was my velocity at exactly 2 hours into the trip? Note my trip's average velocity was 63.3 miles per hour, and my trip's average velocity between 1.5 hours and 2 hours was 80 miles per hour. So we worked that problem, and again, in a different video, I'm going to scroll real quick. It is right here in this table. So this table doesn't have enough data for us to know that. So right at 2 hours, we don't know what speed we're going. We know the distance that we've traveled since we began, but again, all we can do is find an average velocity from there. Okay, so I would say most likely going back to these, so between 63.3 miles per hour and 80 miles per hour, so maybe 70, or maybe I was stopped. Okay, so who knows? Or maybe I was going really fast. Maybe I was going 100. Okay, so we just don't know. Okay, however, if we have enough data, then we could find that instantaneous rate of change. Okay, so, and when you are driving, when you look down at your speedometer, that the speed that it's showing is an instantaneous rate of change, instantaneous velocity. So it's not an average. Okay, so it's that speed, that exact speed that you're going at that moment. Okay, and it's based on calculus. Okay, so we get this definition. And again, this limit as h went to 0 is super important. They call it the derivative. So all that right back to our first box. Okay, so this is the derivative. The way that we say that, so that's f prime of x. Okay, so that is the derivative of f of x, or the derivative of f of x. Okay, so that's how we say it. So it's based on this definition. All right, so if the limit exists, if the limit doesn't exist, then we wouldn't have a derivative. If it exists, we also say f is differentiable at x. Okay, so that means we can do a derivative. All right, so we just talked about instantaneous rate of change. When we plug in a value into x, we would get a numerical value. And then we talked about the tangent line. So let's break this down. So let's see this problem. So here we're just jumping straight to an abstract math function. So we have let f of x equal 3x squared minus 4x plus 2. Number one, it says graph the function. Okay, so I'm going to use my scientific calculator. Or no, I'm not. I'm going to use a graphing calculator. So I'm on Desmos, but let's go to graphing. And then I'm going to type it in exactly the same way. So 3x squared minus 4x. And then plus 2. Okay, so if you have a handheld calculator, you could do this too. I'm just making it bigger. There we are. So we get this. So if you remember some algebra stuff, the x squared is telling us we should have a parabola. Let me make sure I plugged in the right equation. 3x squared minus 4x plus 2. Okay, good. Okay, so we get this curve. Okay, so we have this. All right, now, next thing it wants. So this is the graph. Let me at least label this vertex. Okay, so those are the decimals. Those do happen to be 2/3 and 2/3. And then here we have 0 and 2. Okay, so let's at least make that sketch. All right, so we've got step 1. Let's draw it nice and big. And we had something like that. So it should be a little curvier. So mine kind of is a little pointy. That's okay. Let's go ahead and label that point. That was the 0 and 2. And then this was, let's just put it down here. I am going to just do the decimal that they said. Okay, if you do prefer, I mean, we could change it 2/3, 2/3. Okay, so that's the very quick sketch of the graph using our calculator. Step 2, let's draw lines tangent to the graph at the points with x coordinates -3, 0, and 2. All right, so let's do the first one in red. So we're going to do x equals -3. Okay, so -3 is somewhere over here. So the actual point, let's go back to our calculator. The actual point looks like it's probably pretty up high. Ooh, we got to zoom out. Let's see, where was it? Ooh, yeah, it's way high. So mine, I don't make mine as steep in my picture, but we'll be okay. So up there it was. Okay, so -3 and 41. -3 and 41. Okay, so that's way up high. So this is not to scale. But we could draw a tangent line still. So a tangent line is just going to touch that curve right there the best you can. It would be something like that. Okay, so that's the tangent line when x is equal to -3. Now we've got x equals 0. Let's do that one in green. Okay, so we already have that point labeled, and then let me put that dot down again, and all I want to do is just try to draw a line that kind of just touches it. It would be like that. Okay, so let me try maybe one more time. Actually, I think that's okay. So it really is just trying to show it touches once. It's a little tight. There we go. Okay, so but the main thing, so the reason I kept it, okay, so it still just touches once. Notice that the slope of this one, which we'll call so m tan, so slope of the tangent line, this m tan is steeper than the green one. Then let's say green m tan. Okay, so it's shown dependent on where we are on the graph, we could have steeper or more horizontal tangent lines. Okay, and then let's do this last one in blue. So x equals 2. Okay, so let me go back to the graph. Let's get 2. So 1, 2. There it was 6. 2 and 6. Okay, so we've got this 2 and 6. So somewhere maybe, so again, not to scale. I'm just going to put it right there. Okay, so there's 2 and 6. And again, the tangent line would be something like that. Also, now notice this tangent line in the blue, this tangent line has a slope that is positive. So remember, going up left to right, you'd have mtan being positive. Those other two would be negative mtans. Okay, so we've got these different mtans. Okay, so but that's just us sketching it. Okay, so we'll make sure we can actually know these line equations soon, but here we're just sketching. Okay, number 3. Okay, so number 1 and 2. 1 and 2 is all this in the picture. All right, number 3 is to find f prime of x, so the derivative, by doing this limit. So we've got f prime of x equals the limit as h goes to 0 of this big fraction, f of x plus h. Oops, I drew the parenthesis in the wrong spot there. F of x plus h minus f of x over h. Okay, and so now it is similar to the videos, or similar to the problems that we did here. Okay, so these ones are long. They can take a while. Let's break it down. Okay, so if you want to take a break, maybe take a pause for a second. But what we're going to do is break it down into these pieces. So I'm just going to set up that. Let's leave a little space below this number 3 for now. And then I'm just going to do a star and say I want f of x plus h. I'm going to put that work right here. All right, so we go back to our original function. So our function is f of x equals 3x squared minus 4x plus 2. So just like any function, it's telling us, oh, change those x's right there that I'm underlining into x plus h. So we already did it on the left side. Right side, we'd have 3 parentheses x plus h, then squared, minus 4 parentheses x plus h, and then plus 2. Okay, and then I've got lots of room below, so let's continue doing our work here. This is usually the most amount of steps required in these problems, is doing this step here. All right, so we'd have 3. Now remember, if there's a plus or minus in parentheses and it's squared, we would want to rewrite it to see it multiplied by itself, because we'll need to FOIL. And then that's all I'm going to do on that step. And then now let's FOIL. So to FOIL, let's show it. Let's do this. This x multiplies each of those. Keeping my colors. This 3 is just waiting. Okay, so x times x is x squared. X times h is xh, or hx. Usually we put the x first though. And then let's get the other one. This h would multiply each of those. H times x, we're going to again write the x first, and then h times h is h squared. Okay, and then the parentheses are still there, and then still minus 4 times x plus h, and then still plus 2. All right, and then we can see, oh, these are the same thing added together, so let's simplify. So 3 parentheses x squared plus 2xh plus h squared, and then still minus 4x plus h plus 2. And then now we'll distribute those numerical parts outside the parentheses in 3 distributes, negative 4 distributes. And this becomes 3x squared plus 6xh plus 3h squared minus 4x minus 4h, and then plus 2. Okay, so we got it. On the left, I usually just leave it blank to save a little writing, but that is our answer for that part of the fraction. Okay, so all of that in the blue. Let's rewrite it. Okay, so we've got equal this limit as h goes to 0, big fraction. And now in the blue, I'm going to put that clouded answer that we had. So 3x squared plus 6x there we go, I can see it all. 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 2. Okay, so and we might be a little tight there. I think we could fit it. Okay, so let's extend that fraction bar. Okay, so let's find out. I think I could scroll a little bit further. Ooh. All right, anyway. All right, so there's our f of x plus h. Now in the red, we want that right there. Well, that gave us that. That is this whole thing. Okay, so we'll have minus, and then in the parentheses, 3x squared. So I'm trying to squeeze it in, minus 4x plus 2. Ooh. Okay, so sorry about that. So it goes up a little weird. Okay, but we'll clean it up in the next step. All right, so we plug in that f of x and then still over h. All right, and then now we still continue simplifying. Okay, so this negative distributes to those three terms. Let's write a little bit more left. We have the limit as h goes to 0. Let's get that big fraction bar just set up. We would have a positive in front of this blue parentheses. A positive distributing doesn't change anything though. So we'll just rewrite all those terms. So 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 2. And then distributing that negative over there, we would have minus 3x squared plus 4x minus 2. And then still over that h. Okay, so don't forget that h. We have these big fractions. Also, don't forget the limit. Keep that limit there. And then what's going to happen is most of the time, a lot of terms cancel out. So we have 3x squared and minus 3x squared. That's 0. We do have a minus 4x and a positive 4x. That's also 0. Then we have a positive 2 and a negative 2. And that's also 0. So we're left with just terms that have h in it. Okay, so we would have this limit as h goes to 0 of just 6xh plus 3h squared minus 4h over h. All right, so we're here now. And then what we do is we factor an h out. So notice there's an h in common in all of the numerator's terms. So we're going to factor that out. Let's put it right here. Still the limit as h goes to 0. Taking that h out, we would have h and then 6x plus 3h minus 4. And then still an h in the denominator. Okay, and now that we've got that all simplified, I'm going to change it to green. This h, now that it's factored out, would cancel with that h. So remember that you can cancel if you have products involved. Okay, so like the previous step, we couldn't do any canceling. But now that we've factored, we can. Okay, so those h's cancel. And then we've got, okay, so rewriting it right here. Let me kind of block that off. We have the limit as h goes to 0 of just 6x plus 3h minus 4. And then this is where we plug in the h going to 0. So now it's just kind of like evaluating a normal function. This is telling us change that to 0. And so when we do, this would be, so not the x stays x. So it would be 6x plus 3 times 0 minus 4. Well, 3 times 0 is 0. And so this is 6x minus 4. And now I'm going to cloud it. Okay, so got a little jammed in there. Okay, but then let's just go back all the way. I'm going to put this to the left. All of that work was to find this derivative. So f prime of x is that clouded thing. So I'm going to put number 3's answer right here. So f prime of x became 6x minus 4. Okay, so that is the derivative. And now number 4. So it says find f prime of -3, f prime of 0, and f prime of 2. All right, so f prime of -3. Let's do that one in red. Okay, so f prime of -3. Well, it's still just saying there's an x. So now we have a new function. So don't do f of x, do the f prime. But this acts the same way when we plug in numbers. So it's just saying change those x's into -3. So we would have 6 times -3 and then -4. We could plug that into a calculator. I'm going to do ... and say our f prime of -3 is -28. And let's box that. And then let's get our other ones. I'm going to do this one in green. Okay, so we want f prime of 0. Still, this just highlighting over. Those x's are becoming 0, so 6 times 0 and then -4. I'm just do ... simplify. F prime of 0 is -4. Okay, so there's that one. And then the last one that they wanted was f prime of 2. Let's do that in the light blue. F prime of 2 would be 6, again, changing these x's. So 6 and then times 2 minus 4. Well, this is 12 minus 4. That is 8. There we are. Okay, so those are the derivatives at those x values, which are the numerical equivalent of our slopes. Okay, so back to the picture. It's saying the one in red has a number to it now. It is -28. The one in green has a number to it. It's saying it is -4. Okay, so the slope of that green line is -4. And then in the light blue, they're saying, oh, the actual mtan, which we already knew was positive based on our picture, so notice those matched the signs, is 8. Okay, so it might not match the steepness of what's really needed, but those are the slopes to those different tangent lines. So that's telling us, so these numbers are telling us how quick the function is changing. Okay, so it's a rates of change. It's helping us figure out how fast or slow it's going up or down. Okay, so the -28 slope here is telling us it's going down very fast. The slope of -4 is saying, well, it's still going down, but not as fast as the previous one. And then the last one, mtan equals 8, it's going up sort of fast and up to the right. Okay, so that's it. Okay, so long problem. Tough one, huh? Okay, so take breaks on these. They can take a while. I hope you hung in there. If you do have questions, though, please let me know. And thanks for watching.